Hi, my name is Fida, and today I'm going to be talking to you about two inflammatory players, interferon gamma and platelets. First, we'll begin by talking about platelets. So imagine you're on a warm, sunny beach and you're on a leisurely stroll, soaking up the sunshine when you accidentally step on a glass bottle and cut yourself. And of course, there's bleeding and a wound. In other terms, the endothelial damage from the cut has triggered an inflammatory response. In acute inflammation, which is triggered by endothelial damage, you get the activation of Hageman factors, resulting in the initiation of the clotting system. This system begins with large amounts of thrombin production, which binds protease-activated receptors, leading to platelet activation. In platelet activation, you have cell-shape changes, granule secretion, and integrin activation. This system contributes to clot formation to stop the bleeding. So now that wound needs to heal. Part of wound healing is initial inflammation via a vascular primary homeostatic response. The platelets bind exposed collagen found in the breaks between the endothelial lining of blood vessels. This results in degranulation of platelets and vasoconstriction. In the proliferative phase of wound healing, which can happen during or after the inflammatory phase, platelets secrete platelet-derived growth factor, leading to neutrophil, macrophage, and fibroblast chemotaxis, as well as the stimulation of extracellular membrane production and fibroblast and endothelium proliferation. So say that the cut was pretty deep and you experienced major bouts of infection. A few months later, you notice bruising in the form of purplish-red dots and superficial bleeding. What's going on? Well, it's very likely that you are experiencing an autoinflammatory disorder known as idiopathic thrombocytopenic purpura, in which antibodies produced by B cells and plasma cells attack platelets, accompanied by dysregulation of Treg cells and cytotoxic T cells, leading to apoptosis of platelets. Now, we'll be moving on to interferon gamma, which is an important inflammatory cytokine. So going back to our vacation example, following that endothelial damage and initiation of inflammation, and say any subsequent infections, we're going to get an amplification effect occurring via cytokines like interferon gamma. Interferon gamma is made by natural killer cells and T cells. It acts via the JAK-STAT pathway, binding to interferon gamma receptor 1 and interferon gamma receptor 2 to partake in leukocyte attraction to the site of pathogenesis. It also stimulates macrophages to engage in antimicrobial and anti-tumor functions, as well as antigen presentation. In terms of wound healing, say that the wound is really bad and you'll likely be healing by second intention. You'll enter the inflammation phase where interferon gamma attracts leukocytes to the injury site, eventually entering into the proliferation phase where recent studies have shown that interferon gamma can influence angiogenesis and collagen deposition and subsequent granulation tissue formation. Finally, you're back in London, Ontario from vacation and are still experiencing symptoms reflective of inflammation and lingering infection. In this case, what's happening is that interferon gamma is activating the macrophage, which then presents an antigen to T cells to contribute to its activation, specifically T helper 1 cells, which is involved in cell-mediated immunity, resulting in further production of interferon gamma. So you have this ongoing cycle of activation leading to chronic inflammation. Thanks for watching and joining me on this journey of inflammation. On the following page, you'll see my references.